Hi, I have a video on the pain of electricity, but now I want to kick it up a notch and show you at what voltage it hurts over skin rather than tongue. I'll be trying 120 volt AC, 170 volt DC and 340 volt DC. But I don't have a high voltage supply, so I put together my simple circuit. The circuit looks like this, just two capacitors and two diodes. At this point I apply the 120 volt AC, and across C1 I will have 170 volt DC, and across C2 I'll have 340 volt DC. Please check my website below if you like more detailed explanation. As you see, the voltage levels on this circuit are very dangerously high. You might use this circuit for low voltage applications, but don't use it as I do, or it might be your last day on earth. I made this simple circuit and I'll plug it in. Now the circuit is hot and the voltage is on the Something you must never forget is that some capacitors, like electrolytic ones, are polarized and you must never connect them backwards or they will blow up. Now I have replaced the capacitor on my circuit and I'll plug it in. In addition to polarity, the capacitors must be rated properly to be able to handle the voltage across them, or they will blow up, obviously. I picked 150 microfarad 400 volt capacitors, as the maximum voltage these capacitors will be charged to is 340 volt DC. Now there is nothing to worry about. Like I said, everything is good. There are three voltages on my circuit. The first one here is the 120 volt AC, which is very dangerous. I've accidentally touched 120 volt and 220 volt AC and they hurt a lot and can kill, so I'm not gonna repeat that again. This one here is across the first capacitor, which should be 170 volt DC, and that one there is across the second capacitor, which should be 340 volt DC. Let me measure them for you. To measure the 120 volt AC, I put the meter on AC and I measure the voltage.
Oh my God!
Sometimes when you're probing a line, you might touch the probes, but never forget about the voltage on the probes. Here I have around 120 volt AC on the input, and if I change the meter to DC, you'll see that there is almost no DC on the input. But if I measure across the first capacitor here, you will see that there is around 170 volt DC, which is equal to the peak of the AC signal as expected. This is a much higher voltage and can provide much more power. Now let me touch this voltage. I can barely feel anything, although I feel a little bit of tinkle on my skin. But remember, if my skin is more conductive for any reason, it can hurt much more. I have two light bulbs here that both are 60 watts. I connect one of them to the 120 volt AC input and the other one to the 170 volt. And you see that the one on the 170 volt DC runs much brighter, and I can barely feel that one on my finger. I can even hold the bulb to the 170 volt DC with my fingers. Now let's try the last capacitor. You see there is 334 volts on this one. Let's touch this one. Ouch! Ouch! Well, this one hurts much more, but not nearly as bad as the 120 volt AC. Now let's do the light bulb test. You see the bulb on the 340 volt DC runs much brighter than the one on the AC. And yet it doesn't hurt even close to the AC. The reason is that the human body has a capacitive property that allows the AC signals to run through much easier. And therefore there will be much higher AC current that can hurt or kill a person, while the DC signal is greatly blocked by the resistance of the human body. If you are curious to know how a capacitor behaves, here is a symbol of a capacitor, and these are its plates. When there is a DC signal like this, it hits the capacitor plates like this and gets blocked, while an AC signal can zigzag between the plates like this and pass through.